Welcome back to the lecture series in bioenergy. So, in the last class we talked about the calorific value. So, just to recollect, coming back to the slide, if you remember the slide where we dealt with. So, we are supposed to talk about the moisture content. So, these are all the material properties what we will be dealing with, calorific value which we have done. Then we are supposed to talk about the proportion of fixed carbon versus the volatiles point, ash / residue content. So, there is something very interesting in that, and then followed by the alkali metal content, and last which will be partly a repetition of the cellulosic and lignin ratio. So, what we will do today is we will start with the proportion of fixed carbon and volatiles. Okay. So, this is what we are going to start off with, proportion of fixed carbon versus volatile matters. Okay. So, as we do in every class, in the beginning I will put forward the concept for you, and then we will kind of pull down all the notes which will help you. So, talking about any matter, of course, here we are talking about the biomass or the material of biological origin. They are mostly consist of some handful of elements. The key ones are carbon, hydrogen, oxygen, and if in terms of proteins, then you will have nitrogen, you will have residues of sulfur and bunch of alkali metals, which include sodium, calcium, magnesium, likewise so on and so forth. Okay. Now, each one of these form different kind of bonds with each other. There will be carbon-carbon bond, there will be carbon-hydrogen bond, there will be carbon-oxygen bond, there will be oxygen-hydrogen bond. Likewise, there will be series of such bonds, similarly with all the different alkali metals and everything. Now, what actually determines which material will get transformed into a good fuel? It is determined by the summation of all the bond energies. Okay. So, just for your understanding sake, so if we talk about, you have a bunch of carbons out here. Okay. So, carbon is forming bond with say hydrogen, carbon is forming bond with oxygen, carbon is forming bond with carbon, okay. Maybe carbon is forming bond with nitrogen, and similarly hydrogen is forming bond with oxygen, so on and so forth. Now, what we essentially do, so we will have to integrate or we will have to summate these things in terms of the total bond energy. Okay. So, those of you who remember during class standard 9th or 10th, we used to do an experiment like bomb calorimeter, where we used to measure these kind of values. So, very similar to that, what you are actually measuring, all these different bonds which are forming any kind of matter, what is that total bond energy? Because what will happen is, when you will be breaking these bonds, say for example, you are breaking these bonds, you are breaking this bond, you are breaking this bond. So, these bonds will be generating a certain amount of energy, and for any material, the total energy is again, it will be a summation of these different kind of energies which will be coming out from the bond breaking. So, now if you can categorize all these things, so say for example, this has certain say energy value, okay, say some x joule, okay, this one will have say y joule, z joule, depending on which energy out here is maximum. So, proportionately, if say for example, I say that this material has lot of carbon-carbon bonds, and if I say that carbon-carbon bond has the highest energy, say for example, Z is the maximum as compared to Y or likewise X, just for your understanding sake. So, when I will be converting this by biochemical or thermochemical route, the amount of energy which will be liberated from that material will be higher as compared to, if you compare, again getting back to the chart, if you compare with say this one or this one. So, this kind of gives you an idea that why it is very important that we understand what is the fixed carbon which is present there, because the other forms of carbon may, suppose you burn something in the presence of air, what will happen? Carbon will form carbon dioxide, yet there will be certain carbons which will remain there intact, and similarly the water will form vapor, or there may be hydrogen and oxygen, they may vaporized out, okay, which are trapped in between, and the hydrogen bond will get broken down. So, whenever we take matter, we had to do an analysis where first of all we have to figure out what is the volatile matter present in it. Okay. After that, what is left behind is the carbon material, and from there one can estimate what will be the energy which will be derived out of it. So, after giving you this brief kind of graphical outline, now I will jot down the points which are critical for you people to understand what does this mean. Okay. So, in terms of, if we go by the, in terms of the fuel analysis, if we talk about, one second, okay, we talk about the fuel analysis has been developed based on solid fuel, okay, has been developed based on solid fuels such as coal, okay, which consist of chemical energy stored in two forms. Okay. So, I have already talked to you about the chemical energy, how they are stored, okay. And now I will tell you what are the two forms. Okay. So, the two forms of chemical energy, two forms of chemical energy stored in such materials. I am just putting energy, E for the energy. Okay. One is what we have discussed, volatile matter or volatile content. Sometimes it is also called as volatile content. Okay. And the other one is our fixed carbon, which is denoted by Fc, whereas volatile matter is denoted by Vm. Okay. So, if you come across these things, do not get confused. Okay. So, volatile content or matter of a solid fuel is that portion of the matter which is driven off as gas, including moisture. Okay. So, suppose you take material like this, and this material is, you are burning it at 950 degree centigrade for 7 minutes. Okay. So, this is kind of what has been set. So, this is the material. Now, after exposing it to that, what is driven off out of it will be vapor and several other gas or gas vapor, whatever, you know. So, whatever, so say for example, you take this raw material which has certain, say for example, certain weight is equal to say x. So, the volatile matter is, these are the things which has gone out of it. Okay. Now, x includes, when we talk about the weight x, it includes the presence of the vapor material and the gas and all those things which get transformed. Okay. Now, talking about the fixed carbon is after this. So, after x minus, you have the vapor, weight of the vapor minus weight of the gas. Okay. So, this is all together what is coming out from here. Whatsoever is left behind, this is the x prime. This is the remaining after the release of the volatile. This is the remaining after release of the volatile, okay, of this volatile matters, which includes, of course, which includes ash / moisture. Okay. These are the ones which are being evaporated out. So, whatever is left behind is, this is what we call as the fixed carbon. And having said this, I want to draw your attention to the first drawing what I was doing, where I showed you carbon carbon bond, carbon hydrogen bond, carbon oxygen bond. That fixed carbon what you see is the one which are left with carbon carbon, which is the real core. That fixed carbon, if you can break those bonds, that will generate, if you could, the amount of energy will be fairly high. So, for any material, if your carbon carbon is higher, then you can be rest assured you will be generating more energy, provided you have the technology to break those bonds without spending a lot of energy. Okay. So, to keep that in mind. So, coming back to the slides from here. So, this is the fixed carbon we talk about. So, whenever you do a laboratory test, okay, so these are being tried in the laboratory, as I was telling you, they have different kind of calorimeters which does that, are used to determine the VM and FC content of the biomass fuels. Okay. So, what we do basically for the fuel analysis is based upon the VM content, ash and moisture, with the FC determined by the difference in terms of proximate analysis. So, there is one word which you will come across, which is called the proximate analysis. This proximate analysis is very critical. So, if you go back now where I showed you one of the tables which I gave you in the very beginning out here. So, this is the table which is now is important for you people. Look at this value, volatile mass percentage and fixed carbon percentage. So, if you look at it, the values. So, that is why that table, when I drew this table, I told you that this table will come very handy once we will kind of go through all the material properties. So, if you can see again, looking carefully into the table, you will see that this is the amount which is lost, okay, and what is left behind will come next to this, the ash content. Okay. So, before we come into this, there is couple of very interesting aspects which I wish to discuss with you people. Okay. So, that is basically the proximate analysis. Apart from it, there is another thing which is being done out where we talk about the fixed carbon and the volatile mass, that is called the elemental analysis of the fuel. Elemental analysis of the fuel or of a fuel, whichever way you want to tell it, and it is presented as carbon, nitrogen content, hydrogen content, oxygen content and sulfur together with plus the ash content in terms of the ultimate analysis of a fuel. So, having said this, I again wish to draw your attention to that first table I showed you, where I showed you carbon carbon, carbon hydrogen, hydrogen oxygen, carbon sulfur likewise. So, what you are essentially doing? So, you have a matter, you do a complete elemental analysis. What is the amount of carbon, what is the amount of nitrogen, what is the amount of oxygen, what is the amount of hydrogen. Based on that, you try to draw the chart, how much is the linkage between carbon carbon, how much is the linkage between carbon hydrogen, how much is the linkage between hydrogen oxygen. Based on that, you draw a very interesting chart, and that is where we are now slowly. So, once you know the elemental analysis, so elemental analysis is generally done like burn the stuff and you estimate after the complete burning, charring rather, you estimate the carbon, estimate the elemental carbon, you estimate the nitrogen by Zell-Dahl process, which is the old process. You estimate the hydrogen, oxygen, likewise, and so on and so forth. And there are other spectroscopic technique, modern techniques, where you can estimate them much more easily instead of following the old technique. But these are overall techniques where you do an elemental analysis. So after you do an elemental analysis, what is being done is before I get back to the elemental analysis and to the Van Crevelen diagram, significance of the volatile mass and fixed carbon content. So, they provide a measure of the ease with which the biomass can be ignited and subsequently gasified. They provide a measure of the ease with which the biomass can be ignited, biomass can be ignited, this is very important, and subsequently it could be gasified. These are the different transformation, okay? Gasified, or it could be oxidized, depending on how the biomass is utilized as energy source. This all will eventually be determined based on what form of fuel you are looking into. One is looking into. What does this mean? This essentially means that depending on the carbon, hydrogen, oxygen, nitrogen, sulfur ratio and the water content, what we talked at the first point, intrinsic water, extrinsic water, one decides what kind of transformation should be followed. Shall we follow biochemical methodology by fermentation, or shall we follow thermochemical mechanisms or some other mechanism? What form of fuel do you want? Do you want solid fuel? Do you want liquid fuel? Do you want gaseous fuel? So, it all depends. There are three parameters: what is the product what we want, and what is the methodology we will use. These are governed by these material properties. Now, from here I will come back to where I just left you about that elemental analysis. So, there is a very interesting aspect, so which is called the concept of Van Crevelen diagram. Van Crevelen diagram. What is Van Crevelen diagram? So, I will draw one Van Crevelen diagram here for you people, which will kind of, the diagram itself is self-explanatory. So, you have on the y axis you have atomic H is to carbon, hydrogen to carbon ratio 10, and on the x axis you have atomic oxygen to carbon ratio. Okay. And let me just put the different points. 1 minute. Okay. Now we are done. 0.2, 0.4, 0.6, 0.8. On the other scale, hydrogen to carbon scale, we have 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8. Now, if you look at it, so here I will give you a little bit of a task to do. I will be drawing few cylindrical shape stuff, and I'll explain what does those mean. Okay. Okay. Now, from here there is a third thing which will and then you have fourth stuff which hovers around here, and then you have, I am just changing the color, you will realize what is the significance of it. Okay. Now, what these different cylinders represents. So, this first cylinder, which is now I am putting the hatch lines with orange, this represents anthracite. I will request you people just go online and figure out what is anthracite. Okay. These are different kind of fuels. Second one, which all of you know, I am hatching it in black. This is coal, indicated by the color. Third one, I am putting the red hatching here. This represent lignite. So, please look what is lignite. This is your kind of an assignment, take home assignment. Then next what you have is the pit, which I am now putting together, pit, and the last, which is in green out here, is the biomass. And within the biomass, this is the zone where you have wood, and somewhere out here you have lignin. So, if you look at the, so this is basically what Van Kraebelin diagram tells you. It tells you the significance of oxygen to carbon and hydrogen to carbon ratio on CV, the calorific value of solid fuels. Okay. And comparison of, so do a comparison between fossil fuel versus biofuels, you will observe that there is a higher proportion of oxygen to hydrogen. If you look at this diagram carefully, oxygen to hydrogen ratio as compared to carbon, thus reducing the energy value of these such fuels. Okay. So, as I have already told you, it is mostly on the carbon where most of these energies are stored, and most of this fuel analysis is the value of the biological conversion process. If we know, like, so for example, what does that mean is that these ratios decides what kind of technology has to be used for their conversion. If I know what is the carbon hydrogen or hydrogen carbon or oxygen to carbon ratio, one can make a call that this kind of conversion will be helpful or the other kind of conversion will be helpful. This diagram, again getting back to the diagram, this diagram I wish you should really critically look very carefully. This diagram is kind of you can call it a sort of a snapshot of any material what you are looking at, that how really to evaluate where it stands with respect to traditional fuels like coal and other fuels which are the solid fuels. But of course, this is for the solid fuels, as I have mentioned very clearly, this is exclusively for the solid fuels. Okay. So, this is what we have talked about today about the fixed carbon and volatile carbon. After this, what we will do, coming back to the point. So, still now we haven't talked about this part, the ash. Ash and the, so I am adding one more thing, ash slash residues. So, what we will do next, we will talk about the ash slash residues. So, today we are closing at this point. Please go through the Van Crevelen diagram, and whenever you have confusion about anything, the best way to visualize this whole problem, as I told in the beginning, always look for how many carbon-carbon bonds are there, how many carbon-hydrogen bonds are there, how many hydrogen-oxygen bonds are there, how many oxygen-oxygen bonds are there, and just go to any standard textbook of chemistry or your high school chemistry or class A, standard 8, standard 9, look at the values of those bonds. Those values will give you an indirect measure about how much energy you will be able to derive out of it. Okay, it's a very straightforward deal, but you have to put your logics in place. Okay, so thank you, and please figure out what is pit, what is anthracite, what is lignite. That's as your take home assignment. Thank you.